Hello everyone. So this is a question from JEE Advanced 2026 paper 1. The correct order of dipole moments for the given species is. So we have BF3, NH4 plus NF3 and NH3 to compare. Okay. So the chapters involved is chemical bonding. So in a polar molecule, for example, let's say HCl, one end of the molecule is negative, that is the Cl end, and the other end is, that is the H end, is positive, that is it has partial negative charges, it has partial positive charges, right? And the molecule as a whole is neutral, so therefore the negative charge, that is delta minus, is equal in magnitude to the positive charge, that is delta plus, right? That is magnitude of the negative charge is equal to magnitude of the positive charge. Now, the product of magnitude of either, that is either of the negative charge or of the positive charge, and distance between them is called the dipole moment mu. So mu is equal to magnitude of either the negative, or you can also write the positive charge, into the distance between them. So this is the distance d. Okay, and mu is a vector quantity, important. Okay, and it is represented by an arrow. So it is represented by an arrow with its tail at the positive center and head pointing towards the negative end. Okay, for example, in case of HCl, so we know that this is the positive end, this is the negative end. So the direction of the vector dipole moment is like this. Okay, so the tail is at the positive center and the head is pointing towards the negative end. Okay, in polyatomic molecules, mu is equal to resultant dipole moment of all the individual bonds. Very important. In polyatomic molecules, those molecules which contain many atoms, mu is equal to resultant dipole moment of all individual bonds. Okay, and the magnitude of this resultant dipole moment depends upon the values of individual dipole moment, obviously, and also their arrangement in space. Very important. That is, they might have individual dipole moments, but still the resultant can be zero. So that's why the resultant dipole moment depends upon values of individual dipole moment of the bonds plus their arrangement in space. That is also important. Okay, so in case of symmetrical molecules, very important, symmetrical molecules. And when I say symmetrical molecule, a molecule is symmetrical if the central atom is linked to similar atoms, plus there is one more condition, it should be surrounded by only bond pairs. There should not be any lone pairs on the central atom. So these are the two conditions which makes a molecule symmetrical. Central atom should be linked to similar atoms, plus central atom should be surrounded by only bond pairs. Okay, for example, BF3 NH4 plus. Okay, BF3 is trigonal planar. So you can see the central atom boron is surrounded by similar fluorine atoms and there are no lone pairs. So this is a symmetrical molecule. Same thing applies to NH4 plus. NH4 plus is tetrahedral and it can be represented like this. So you can see central atom nitrogen is surrounded by similar atoms And also there are no lone pairs. There are only bond pairs around nitrogen central atom. Okay. So coming to the point, symmetrical molecule, in case of symmetrical molecules, the resultant dipole moment is always equal to 0. For them, the mu resultant is always equal to 0. Okay. As the individual dipole moment cancel out due to symmetry. Okay. So with respect to diagram, in BF3, the individual dipoles direction will be this. As fluorine is more electronegative, so partial negative charges are here, and boron will have 3 partial positive charges, right? So these are the individual dipole moments, and the resultant of these two will be here, and this cancel out, so the overall dipole moment is equal to 0. Here also nitrogen is more electronegative than hydrogen, so therefore nitrogen will have negative charge, hydrogen will have positive charge. Okay, so partial positive, partial positive, partial positive, and partial positive, and the individual dipole moment will be represented like this, and nitrogen will have obviously -4 partial charges. Okay, so since this molecule is overall symmetrical, the resultant of these vectors is 0. They cancel each other. Okay, so therefore here also the resultant dipole moment is equal to 0. So therefore I can write mu of BF3, that is dipole moment of BF3, is equal to dipole moment of NH4 plus, which is equal to 0. Next we have to talk about NF3 and NH3. Okay, first thing is that they are not symmetrical. Okay, so that's because they have a lone pair on the central atom, that is nitrogen. On both there is a lone pair on nitrogen, which makes them asymmetrical. Okay, and so they look something like this, and both are, they have pyramidal shapes. Okay, and also dipole moment between lone pair and nitrogen atom, this and nitrogen atom has to be considered in both of them. Okay, and the direction is, and the direction of the dipole moment is in the direction of lone pair. That is, this is how we show the dipole formed between lone pair and the nitrogen atom in both. Okay, and fluorine is more electronegative than nitrogen. Okay, because the electronegativity of fluorine is 4, for nitrogen it is 3. So therefore the dipole moment of NF bonds, that is these bonds, has direction from N to F. So they will be shown like this, as fluorine is more electronegative. Okay, and nitrogen is more electronegative than hydrogen. Nitrogen has a value of 3, hydrogen has electronegativity of 2.1. So therefore the individual dipole moment of NH has direction from H to N, as nitrogen is more electronegative. So they are shown like this. Okay, in NH3, that is this guy, resultant dipole moment of NH bonds, that is the resultant of these three, will be something like this. So it adds up to the dipole moment of the lone pair. Okay, in the case of NF3, the resultant dipole moment of NF bonds will be like this, and it cancels out the, I mean, it partly cancels out the resultant moment of the lone pair, because both are in opposite directions. Okay, here they were in similar directions. So therefore the dipole moment of NF3 is lesser than dipole moment of NH3. Okay, here the resultant of these three add to the dipole moment with the lone pair. Here the resultant of these three cancels out with the dipole moment with the lone pair. Okay, so therefore here dipole moment is less, here it is more. And to be specific, the dipole moment of NH3 is 1.47 debye, and the dipole moment of NF3 is 0.24 debye. Okay, so therefore the correct order is going to be BF3 will be equal to NH4 plus, both are 0 debye, 0 debye. NH4 plus will be less than NF3, whose value is 0.24 debye, and NF3 will be lesser than NH3, whose value is 1.47 debye. Okay, so therefore option A is the correct option. Okay, thank you.